Okay guys, good morning and welcome to your Algebra 2 class. Today we're going to be talking about factoring polynomials, and we're going to be talking about factoring polynomials by a method called grouping. We already know what a polynomial is. It's a series of one or more terms, or in other words, it's a series of one or more monomials, because a monomial is one term, binomial is two terms, trinomial three terms. We know the degree of a polynomial because it is the degree of a polynomial belongs to the highest degreed monomial. We know how to add polynomials now. Remember, only like terms can be added. So that means only numbers, only monomials with the same variable raised to the same power can be added. We also learned how to multiply polynomials. We know how to multiply a monomial to a polynomial. We know how to multiply two binomials. And we know how to multiply binomials by trinomials or n-term polynomials. So we've actually learned a lot, and I'm very proud of you. Today, we're going to get to the real nuts and bolts of polynomials, what they're really good for. It's for factoring, and then we're going to use that factoring later to solve what's called quadratic equations, and then later cubics and all that good stuff. So this is a very, very basic building block that is important for the development of your algebra skills. So sometimes you will have four-term polynomials which need to be factored. This is a very easy process which involves factoring out the GCF, remember the greatest common factor, from binomials, whereby you create identical binomials. Here's how it works. Because that little synopsis is nice, but that's nice for me who knows what I'm doing. For you, that may have been a little confusing. So I made this really, really nice, okay? Really, really easy to understand. They want you to factor the polynomial 3n squared minus 12n plus 2n minus 8. Okay, I have a procedure list over here. Number one, group two terms, forming two binomials using parentheses. So when you do this, guys, group the first two and group the second two. Notice how I kept the sign of that coefficient inside of the parentheses. You have to do that, okay? Do not put it on the outside. In between here, just put a little plus. So this is the way it looks nice and pretty. Okay? Let me redo that again, just in case you didn't see that. Parentheses around the first two. Parentheses around the second two. You're not multiplying these, so you got to put a plus in the middle. That's what this came from. But notice how this plus sign stayed inside of the parentheses. Please, that's very important, especially when they're negative. So keep them inside the parentheses. Does that make sense so far? Number two, factor out the GCF of each binomial, which leaves you with two identical binomials. Okay, just out of curiosity, what's the GCF for 3n squared minus 12n? 3n. Beautiful, guys. What's the GCF for 2n minus 8? 2. Okay, check this out. Remember that when we factor out a GCF, we got to put the GCF on the outside. Remember, it's GCF times leftovers, right? Right, guys? Okay, so this is what it would look like. When I factor out the 3n squared divided by 3n is n. Negative 12n divided by 3n is negative 4n. Plus, remember we kept that plus, that's why it's so important. Factor out a 2, 2n divided by 2 is n, negative 8 divided by 2 is negative 4. Is everyone with me so far? Okay, now from here, step 3, factor out the common binomial and group the GCFs as its own binomial. What's common to this term and this term? So, remember the rule? The GCF times the leftovers, right? So the GCF is n minus 4. And what are the leftovers? 3n plus 2. I heard a 6n, and I thank you because you're working and you're participating. I'm very proud of you. They're not multiplied, Bubble. You're not multiplying them. It's n minus 4. That's the binomial, right? That was common to both terms, correct? And then what am I left with? A 3n and then a plus 2. Do you guys see that? You promise? And then that's what it would look like, nice and pretty. Either way, the n minus 4 could go in front. That doesn't matter. Yes, sir? Come again? Oh, yes, sorry. My bad. Thank you. Yeah, this is multiplied. Yes, thank you, son. Sorry. My bad. Way to go, Jimmy. As always. No, no, no. I'm very proud of you. Thank you. Way to go. As always. You earned that. Good for you. Yes, sir. If I foil this at the bottom, I give you my word of honor. It gives you the top. In fact, that's a great way to check. Thank you, son. That's a great way to check. Okay? May I continue? Okay, boys. All right, let's check this one out. First thing I'm going to do, I'm going to go ahead and set it up by separating my two binomials, putting a plus in the middle, keeping that sign of the positive 16 inside the parentheses. What's the common, excuse me, gentlemen, what's the common factor of 4q to the fourth minus 10q to the third? 2q to the third. 2q3 is really this, son. 2q3 is that. I'm not trying to be a jerk, but you guys got to learn how to speak math. 2q cubed, or 2q to the third power. So I pull out my 2q cubed. It's like a tongue twister. What's left? What's 4q to the fourth divided? 2q minus 5. Awesome. Now, what's the greatest common factor of this bad boy? 4q or 8q? 8q, yes. Positive 8q. So I'm going to be left with 2q minus 5. You know that you're doing this correctly if both binomials are identical. If you have a 2q minus 5 here but a 2q plus 5 there, you did something wrong. Okay, they got to be identical. Now, looking at this term and looking at this term, what is the common factor between those two terms? So we take out the 2q minus 5. Now think about it, guys. These are gone already. These are gone already. I don't want you to be confused. What am I left with? 2q to the third plus 8. Wait, no. Yeah. Wait, okay. 8q, okay. Look at what happened here. I have these extra q's here, right? So I can factor out another q from there. So I can have at the end here a q, 2q minus, actually a 2q, q, 2q minus 5, and then a q squared plus 4. Okay, did everyone see that? Now, there's an easier way to do this. I was just so jazzed on doing I didn't go through the whole steps. So I'm going to blow you away right now. I'm going to erase it all. Don't worry, don't worry, don't worry. Whenever we're factoring, whether we're factoring by grouping or later we're going to learn how to factor trinomials in two different formats, the first thing you always want to do is factor out the main GCF. So what's the main GCF, if possible? 2q. So let's start like this to make your lives easier. Then you'll have 2q squared minus 5. No, it'd just be 2q to the third, sorry. 2q to the third minus 5q squared, right? Plus 8q minus 20q. Okay? And there's no q there. Okay? Now from here, let's group it. This guy stays there the whole entire time. Now, this, so now I have 2q, right? And then I have times, take out my 2q, my q from here only, right? Q squared. So I got a q squared, and I've got left over 2q minus 5. And then from here I take out, no, just a positive 4, because I want that negative 5. So I take out a positive 4, and I got my 2q minus 5. And then it's the same thing. 2q times my common factor of 2q minus 5 times my leftovers of q squared plus 4. That way you don't have to do it all and then redo another factoring. That's a bit of a mission the way we did it the first time. This is the right way to do it. Factor out your GCF first, then attack what's left over. Does that make sense? Sure, my brother. Yeah. Sometimes there will, a lot of times there won't be a GCF for all of them, sir. Does not always have to have a GCF for all of them. Thank you for asking. Okay, now. Okay, how about this bad boy? Okay, how about this bad boy? Do I have a GCF amongst all of them? No. So here, though, is very important. Look at the negative 5, guys. Please pay attention to this. Boom. Keep that inside, and that's plus. So I'm going to factor out a 2r squared. So I got 2r squared. I'm left with r plus 6. Now from here, what do I have to factor out of here to make it a positive r plus 6? Thank you. So take out the negative 5 in that case, and now I have r plus 6. My common factors are the r plus 6 times my leftover of 2r squared minus 5. Do you see how important that is to keep that 5 there, that negative? Do you guys see that? Promise? Yep. Okay. Everyone got this? Yes? No? Maybe? Kind of? Sort of? Guys, I got to move on. Do you have this or not? Yes, sir. Yeah, I factored out a negative 5. Negative 5 divided by negative 5 is positive r. Negative 30 divided by negative 5 is positive 6. I pulled out the negative 5 because I have to keep my negative 5 outside. Remember, it's GCF times leftover primes. Thank you. Does that make sense, boys? Now, sometimes they won't make it so easy, okay? Sometimes that's the exact, by the way, this is the exact link. So when I click on it, that's what you should see. So this way, when you do go to CUDA, if you don't have these, 6 problems exactly the same, then you know you did it incorrectly, okay? So let's go ahead and close that out. Yes, that is the homework, sir. That's why I showed you. Yes, it's what I had said in the beginning of class. Thank you for paying attention. Okay, now, in this particular case, guys, I want to stump you. First of all, can I factor out a GCF? A 4. Yes. So if I factor out a 4, I'm going to be left with 2p cubed plus 7p minus 8p squared minus 18. No. Yeah, hello, 18, 28. Yes, thank you, son. Now, pay attention because something weird's about to happen here, okay? Just relax. They don't always have to be in standard form. No. This is what always has to happen, though. Guys, do I have a common factor here? Yeah, so I can have a 4p, and then I have 2p squared plus 7. Huh. What can I factor out of this to make it look like that? A negative 4. Exactly. This didn't work out the way I wanted it. So then this is going to be 2p squared, darn it, plus 7. Okay, that's not what I wanted. Arg. Arg. Oh, I'm not happy about that. I wanted this to come out messy. Okay, so then this is going to be 4 times 2p squared plus 7 times p minus 4. Darn it, I wanted to trick you, and it didn't work out. Let me find another one right quick. I know I'm sounding evil, but I'm trying to help you guys. Because sometimes it's not always going to work out perfectly. Okay? Sometimes it's not going to work out perfectly. Okay. How about if I gave you this, guys? Oh, wait. No, I don't want this one yet. Hold on. I don't want this one yet. Hold on. Let's add a new page. What if I gave you this, gentlemen? Okay. 6 6q to the 4th minus 12q minus 24q squared plus 3q cubed. Okay, let's see if this time I can stump you. Let's see. See if it works out this way. We go like this. Oh yeah, first of all, yeah, let's factor out a 3q. So when I take out a 3q, I'm left with 2q cubed minus 4 minus 8q plus q squared. Now let's go ahead and put these together. Come again? There are no like terms here. No worries. Thank you, sir. So now let's factor out a 2 from here, right? So I got 3q. Then I've got 2 times q cubed minus 4. Yes, this is going to work. And then from here, I take out a q, right? Yes. Minus 2. Okay. Q cubed minus 2. But here, if I take out a q, I'm going to have a positive q, and then I have a negative 8 plus q. Are these guys the same? No. So what happens there, in this case, when you can't group it out to make it pretty, you have to rearrange. You have to rearrange the whole entire thing. So this goes back to what Danny was saying. Sometimes, most of the time, okay, you can rewrite everything as a standard form, but easier and quicker than that, whenever you see that it doesn't work in the way that it's given to you, switch this guy for that guy. So let's rewrite this by switching just the middle terms. 6q to the 4th minus 24q squared minus 12q plus 3q cubed. Let's still factor out a 3q. So I'm going to have 2q cubed minus 8q minus 4q minus 4, thank you, plus q squared. Let's go ahead now and group this suckers. I'm going to take out of here a 2q. So I have 3q, and then I have 2q, and then I got q minus 4. And then from here, I take out, yeah, that's right, q squared. So here it's already done. So what do I factor out of here, though? A 1. So you go plus 1, and you got q squared minus 4. You guys with me here? And then this would be 3q times q squared minus 4 times 2q plus 1. And just so you know, this is not the final answer. This can be factored as well. Does that remind you of a special case multiplication? Guys, isn't this q squared? And isn't 4 2 squared? So that factors out to q plus 2, q minus 2. Yeah. Isn't this the sum of the difference of 2 squares? We're going to get into that, but that's why I'm not going to finish this yet because I want to confuse you. But do you understand the whole switching procedure here? Switch the middle 2 if it doesn't work the way it's given. If it doesn't work after you switch those 2, And it's called prime. It's impossible. Sir.
Can you do the little the square thing? Didn't you circle the head?
Yeah, Papa?
When you factor that, can you have like 3?
Yeah, but we'll get to that. Yes. The real answer for this is going to be 3q times q plus 2, q minus 2, times 2q plus 1. That's the real answer. But I haven't shown you how to factor this yet. So we'll get to that. What I wanted to show you from this example was this, guys. If it's not working in the form that they give you, switch the middle terms. Sir, and then sir. Is there any way to see the first part of it? Well, in this case, yes, in my opinion, there is. Because what I did in my head, if I take out a 6q here, right? In my head, I'm going to see a q cubed minus 2, right? Am I going to be able to get the same thing here? No, when I take out a 3, I'm going to have an 8q squared, right? That's not going to work. But that comes with time and experience, okay? Does that make sense, boys? Okay, now, last thing I want to teach you guys. I'm going ahead, but I can see why it's better to teach it this way. I promise you, if you don't like this method, that's fine. I don't use this method. Why are you teaching it? Some people love this method. This is factoring a trinomial in the form of ax squared plus bx plus c. We're going to learn that on a whole separate day. I give you my word. And I'm going to teach you how to do this using the Cuban method. Now, the quadratic formula, that's for solving unfactorable stuff. We're going to be dealing with stuff that is factorable. And at this point, we still won't use the quadratic formula, even if it's not factorable, because we're not solving yet. That's coming soon. Okay? I'm going to show you what's called the Cuban method to solve this. Now, some people do not like the Cuban method. So I'm going to show you how to do this by grouping. Number one, whenever you see this in this form, and you have a number, a coefficient in front of the x squared, this activates this procedure, okay? And all you got to do is concentrate on this middle term. Look at the middle term, okay? When it's in this format. If it's like this, don't do that. Don't. When it's like this, do this, if you like this procedure. What number plus what number equals the middle term here, guys? Huh? Negative 12 and 2x, correct? Negative 12x plus 2x equals negative 10, correct, guys? You with me? Okay. Group the two numbers with the first and the last. So 3x squared and the negative 12x. And then the 2x and the negative 8. Yes, sir?
Why can't you use like...
Well, let me just finish this first, and then we'll go through all the other things. Please, I'm not trying to be rude. Thank you. Now, let's go ahead and factor by grouping. See if this works. From here, I pull out a 3x squared from a 3x from this guy, and I pull out a 2 from this guy. And then at the end, I combine the x minus 4 and the leftover 3x plus 2. Oh, and that is not a plus. Did you guys see what I just did there? Okay, now, I know that some of you had said different numbers, so let me go over this. This is why I don't like this that much. Why could I not have used negative 7x and negative 3x? Oh, wow, but that's already using the Cuban method. Very good. Okay. So we're going to have to add some Cuban method in this as well. Okay. Yeah, but if I teach it like that, then I should just teach the Cuban method. Hold on. Let me show you why this doesn't work. If you have negative 7x and minus 3x, okay? When you put the 3x squared minus 7x, and then you have plus negative 3x um, minus 8, and you try to group these, are you ever going to make those binomials look equal? No, that's why that doesn't work. Somebody said, oh, negative x and negative 9x. Okay. If this is negative x and this is negative 9x, are those ever going to look the same? No. So you have to find a combination, okay, that works. Now, what's a nice, easy way to find a combination? Do it like this. What number plus what number equals the middle term, comma, but when multiplied equals the last term. Equals the last term times the first term. So what's the first term times the last term? What's 3 times negative 24, right? Okay, now, negative 12 plus 2x is negative 10x, right? And what's negative 12x? What's negative 12 plus times positive 2? Negative 24. So that's how I know that this works. Again, this is not my favorite method, but I got to teach it. I got to teach it. It's just the way it goes. Does that make sense, guys? Okay? You sure? Now, I promise you, if you're stressing about this, try it this way. We'll go through it tomorrow. But I promise you, I'm going to teach you a much easier way. I promise. It's more or less the same thing, but it's quicker. Sure. In the test, I'm just going to say factor. You use any method you feel like. May God bless you all and have a wonderful day. Hold on. Hold on.